Okay, this is a quick video to talk about making solutions where we know the molar concentration of the solutions, and we're going to do it two ways. We're going to make it from solid solute, and we're going to make it by diluting a stock solution of the solute. So I will show you both ways. So we're going to make identical solutions, one starting with solid solute and one starting with a stock solution of the solute. Okay, so first we're going to make a solution of urea. I apologize, in the conversion to explain everything, we lost our subscripts, so please, just make note of that. So we're going to start with urea, and it has a given molecular weight, and the question wants us to describe how would we make 7.50 liters of a 2.40 molar solution of urea, starting with solid urea. Whenever you are making a solution of known molar concentration, the first question is, how many moles of the solute do you need? Right? So to find out how many moles of urea that we need, we start with our solution, right? We want to end up with a solution that has 2.40 moles of urea per liter of solution. And our problem tells us that we need 7.50 liters of solution. And so if we multiply that, we find out we need 18.0 moles of urea. Okay, so the most important thing is always, how many moles of the solute do you need? That's always the starting point in making a solution of molar concentration. Okay? Now, the problem is urea is a solid. We're going to weigh that solid on a balance, so we need to find a mass. And so we go back to our relationship. We know the molecular weight, so we have 18.0 moles of urea that we need. We know that there are 60.06 grams of urea in 1 mole of urea. And so when we multiply that out, we end up with 1,081.08 grams of urea. Now, we have extra significant figures here, but our extra significant figures won't hurt, because if we, when we get to the balance will determine what we can weigh. So let's assume we have a balance that will weigh to the nearest tenth of a gram if we're weighing over 1,000 grams. Okay, so our balance will weigh to a tenth of a gram, so that would mean that we're going to weigh 1,081.1 grams of urea, if we can get there. Okay, so what would we do? Because the question asks us to describe. Okay, so how would we describe this? So one, we would weigh, or mass, as some people prefer, 1,081.1 grams of urea. 2, we would place it in a 7.50 liter volumetric container. And remember, beakers and Erlenmeyer flasks are never volumetric containers. So this would be a graduated cylinder or a volumetric flask. Those would be considered volumetric containers. 3, we would dissolve our solid in water, since we wanted to make an aqueous solution. We would dissolve it in water, which is less than the 7.5 liters. Right? Dissolve it in water to some volume less than 7.5 liters. And then the last thing when you're making a solution of molar concentration, because remember, molarity is about how many liters of solution you have, right? It's the total final solution volume that's important. So the very last thing you do is add water. Some people want you to say with stirring, because mixing does affect the volume, to the final volume, which is in this case 7.50 liters. So that's how you make a solution of defined molar concentration, starting with solid solute, right? Your solute is coming from a solid. Okay? Now, what if we're asked to make the same solution, but instead of having a source of solid urea, our source of urea is a pre-made solution of urea with a concentration greater than the concentration of the solution we're trying to make. That's essential, right? Your stock solution has to have a concentration greater than the concentration of the solution that you're trying to make. Otherwise, it won't work. You can't dilute a less concentrated solution and make it more concentrated. So let's look at this. But as I said the last time, when you're making a solution of defined concentration, the most important thing is how many moles of solute do you need? So again, we start, if we have 2.40, we want a solution that's 2.40 moles of urea per liter of solution. And we want to make 7.50 liters of that solution. That means we need 18.0 moles of urea. Now, we're getting that urea from this stock solution. And so the question is, what volume of that stock solution do we need to give us this much urea? So, we start with that 18.0 moles of urea. We know that 1 liter of the stock solution contains 8 moles of urea. And so that tells us then that we need 2.25 liters of our urea stock solution to give us the 18 moles of urea that we need, right? The 2.25 liters of urea stock solution is providing the 18 moles of urea that we need to make the solution that we want to make. Now, note, here I'm making a solution of high concentrations, and so it makes sense to measure this large volume in liters. If you're making a solution where this volume came up less than 1 liter, it would make most sense to convert the liters to milliliters, because you have to think about, in the lab, how are you going to measure this? If you've got less than 1 liter, you're probably going to use a graduated cylinder, and a graduated cylinder is going to be graduated in milliliters in this case. But because we're working with a large volume, we'll leave it at 2.25 liters. So that 2.25 liters provides our 18 moles of urea. And so now we just have to describe how we would make our solution, right? So we're going to measure 2.25 liters of the urea stock solution into a 7.50 liter volumetric container. Remember, a volumetric container is either a graduated cylinder or a volumetric flask. And now, right, our solute is already dissolved in that. And so all we have to do then is what is always our final step when we're making a molar solution. We add water to a final volume, in this case of 7.50 liters. Some people like you to express that you're doing it with mixing, because again, mixing does affect the volume of a solution. And that would give our 2.40 molar solution of urea. So, I hope this was helpful. This is two ways of making a solution of a known molar concentration. Once from the solid of the solute, and once if the solute is already dissolved in a stock solution of higher concentration than the solution that you want to make.